Okay, Mr. Gasson here with our next lesson. Today we are going to talk about solving equations. We have two learning targets today for solving equations, so make sure to write these down. First learning target is students will be able to demonstrate solving addition equations, so you're going to show that you can do that. And then the second is that you will be able to write equivalent addition equations. Okay, so not only can you solve them, but can you write equivalent equations, equivalent meaning representing the same amount. Alright, if you need to pause to finish copying those down, go ahead. Otherwise, I am going to move on to the next lesson, the next page. To solve equations, two things that we're basically going to be working on. First thing is you must do the same thing to both sides. So whatever you do to the left side of the equation, you must do the same thing to the right side of the equation. The other thing is when you solve equations, you want to use the inverse operations. So our inverse operation of addition is subtraction. And then our inverse of subtraction is then addition. So they are going to work together. And then for multiplication, our inverse operation is division. And for division, our inverse operation is multiplication. Okay? If you need to pause to write those down, go ahead. Otherwise, I'm going to be moving on. Oops. In example 1 here, what do you do to solve an addition equation? Okay, first couple examples we're going to be talking about just what do you do. So if I have x plus 23 equals 47, the inverse operation, here's my x, I'm adding 23 to it. So to solve it, I'm going to undo it, and I'm going to get the variable by itself. So since I'm adding 23, the inverse is to subtract 23. So what am I going to do? I'm going to subtract 23 to both sides. Right now, we're not worrying about solving it or anything. We're just finding out what to do. What do? You subtract 23 to both sides. Okay. Example B, right here. What do I do to solve this? X plus 12.4 equals 56.8. Again, here's my variable. I'm adding 12.4 to solve. I'm going to undo that. So I'm going to subtract 12.4 to both sides. So I'm going to write that. Subtract 12.4 to both sides. So for the first couple, you just have to explain what you need to do to solve them. Okay, that's example 1. If you need to pause, go ahead. Otherwise, I'm moving on to example 2. In example 2, it says write the equivalent equation. When it says write the equivalent equation, what I want you to do is solve for it. What does x represent in this problem? It says x plus 15 equals 87. Here's how you have to show your work in class in order to get full credit. So when I say show your work, this is what I'm referring to. It says x plus 15 equals 87. So again, x adding 15, so the inverse operation is to subtract 15. So I'm going to subtract 15 to both sides. I'm just going to write it underneath my plus 15. 15 minus 15 is 0, so that leaves me with my x is left on the left side. On the right side, I do 87 minus 15, which is 72. There's my work. There's my answer. Okay, work and answer. So make sure that you have that for every problem where I ask you to write the equivalent equation. Okay. I'm going to move on to problem B if you need to pause. In problem B, we have x plus 3.5 equals 10 3/4. So again, here's my variable. Always got to locate your variable. I'm adding 3.5. So the inverse, to undo that, I'm going to subtract 3.5 to both sides. So I subtract 3.5 from both sides. Okay. 3.5 minus 3.5 is 0. So that leaves me with x equals. On this side, I'm going to subtract. I'm going to make these common denominators, so that's going to make that 2/4 instead of 1/2. All right, I can subtract those. 3 minus 2 is 1. Denominator's 4 stays the same. 10 minus 3 is 7 is my whole number, so I get 7 1/4. Again, there's my work, and there's my answer. Okay, you must have your work and your answer. So this is writing the equivalent equation, which means solve the problem. When I say write the equivalent equation, I mean solve the problem. Okay, I'm going to move on to example 3 if you need to pause. In example 3, this time I want you to create an equivalent addition equation. So when I ask you to create one, I want you to create an equation, okay, and in this equation, it must have the same answer. So the first thing you need to do is figure out what x equals. So again, I'm adding 21, so the inverse is to subtract 21 from both sides. That is going to give me x equals 17. Okay, that isn't that's just helping me answer and write to create my equivalent equation. To create my equivalent equation, I'm going to write another equation where x is 17. So the equivalent means that they represent the same value. So for this one, I'm going to, here's a sample, I'm going to do x plus 15 equals. Now I have to think about what would be an example there. Remember, x is 17, so that helps to put it there. 17 plus 15 is 32. So my equivalent equation would be x plus 15 equals 32. If I wanted another example, I could do x plus, let's do, I don't know, 42 this time. Plug in the 17 to help me. That's 59. So I put 59 there, and that'd be x plus 42 equals 59. There's two examples of creating an equivalent equation right there. Okay, I'm going to move on to B if you need to pause. For B, I have x plus 11 equals 45. So again, figure out what x equals. That is going to be 34. After I figure that out, now I can plug that in to see how it works. So again, here's an example. I can do x plus 30 equals, remember that's 34. If it helps, write that down. That equals 64. So x plus 30 equals 64. Or I could plug in x plus 19 equals, let's see, plug in the 34 there, and that is 53. So you get x plus 19 equals 53. So that's how you create an equivalent addition equation. So the difference between creating means I want another equation with the same answer, and write the equivalent, which means find the answer. Okay, that's the difference between examples 2 and examples 3. Okay, answer your questions and fill out your summary on the form, and I will see you in class tomorrow. Have a great night.